Hello, everyone. Thank you for joining us from wherever you are. My name is Ian Boatman, and I'm a meteorologist here at the National Weather Service in Wilmington, North Carolina. Today, we continue our South Carolina Hurricane Preparedness Month Hurricane Hazard Series, focusing on rip currents and offshore impacts. We've been coming at you every week all this month telling you about the different hazards of a hurricane, strong winds and the tornadoes, the storm surge and the other coastal impacts, the heavy rain and the inland flooding that results from it. Today, we focus on rip currents and offshore impacts. The next week, Melissa Griffin from the South Carolina State Climate Office will come at you, focusing on South Carolina hurricane history, which I know will be a really good talk. Focusing on today's hazard, rip currents, we'll start with this fact. Did you know that over the last 10 years, about 10 to 15% of U.S. fatalities from tropical cyclones were caused by rip currents? Tropical cyclones produce all of these hazards, right? The storm surge and the tornadoes and things like that, which are usually pretty easy to see. It's kind of hard to mistake a tornado. It's very obvious what storm surge flooding is. You know what wind damage is from the amount of downed trees and power lines, for example. The rip currents are sort of a silent killer. They're not as blatantly obvious, but they play a big role in coastal hazards for hurricanes. Nearly 90% of all tropical cyclone-related deaths are water-related. Storm surge, rain, surf, and other marine. Unfortunately, that rough surf hazard can easily be overlooked or underestimated because it's that kind of a silent killer, especially with distant tropical cyclones that may be hundreds of miles away, even thousands of miles away. Many of these fatalities, about 10 to 15%, occur due to storms that were well offshore. That's a big pattern around here. In South Carolina alone, 9% of rip current fatalities going back to the year 2000 were caused by tropical cyclones. So this is a big relevant thing for this area across not just South Carolina, but both of the Carolinas. Well, let's zoom in on this. What are rip currents exactly? Rip currents are channelized currents of water that flow back into the ocean from the shoreline. You have your regular old incoming waves that come into the shore, no different from any other day, right? But some of those incoming waves, after they've made it all the way to shore, they'll get immediately jetted back out. They start back into a feeder, which feeds into a narrow neck of water that eventually spills out into the head of the rip current somewhere offshore. Is that 20 yards offshore? Is it 100 yards? Could be anything, because there's a lot of variance as to how strong rip currents can be. Rip currents typically form at breaks in the sandbars and near structures like piers and jetties and things like that. Rip currents are extremely common along any stretch of any beach with breaking waves, along the Atlantic, the Gulf, the Pacific, you name it. Even along the Great Lakes beaches. The Great Lakes being so big, they're basically like a miniature ocean, and they experience rip currents just as much as we do here in the Atlantic Ocean. Rip currents are extremely fast. Think of these as just little mini rivers or treadmills even that move out into the ocean, usually on an average about 1 to 2 feet per second. But they can go as fast as 8 feet per second. That's faster than the average Olympic swimmer. Okay? So, not a good idea to fight this, right? I don't care if you're Michael Phelps, all right? Not a good idea to fight against a rip current. How do you get out of these things? The number one rule, first and foremost, do not panic. Okay? Which I know is easier said than done, but that's the number one rule, to do not panic, because that's when you start getting yourself in trouble. Try to stay as calm, cool, and collected as you possibly can, because the rip current itself does not pull you under. That's a common misconception. You get pulled under because you're fighting it so much and you get tired and your body starts to tire itself out. But it's not necessarily the rip current in and of itself that's pulling you under. Do not swim against that current. You swim out of the current and then to shore. So if I'm caught in a rip current, and let's say it's pulling me out in the ocean, maybe the ocean is towards the camera here, and it's pulling me outward, I need to go away. So I need to swim away and out from the current, either this way or this way, okay? You go out. When you go out, you eventually leave that rip current behind, and then you're able to gradually make yourself back to shore. If you cannot escape, float or tread the water the best you can and wait for help. This is also why it's really important to swim at a beach that has lifeguards, okay? So check in with your local beach rescue team and see if they have lifeguards around patrolling the beaches. It creates a safer experience for yourself and everybody around you. How do these things form? How does a rip current start? The rip currents form as incoming waves push water against the shore, and to remain in balance, that excess water finds the least path of resistance and quickly jets back out into the ocean as a rip current. Rip current formation is favorable with three particular ingredients in play, highlighted in blue there. Incoming waves that are perpendicular to shore. They don't come at you at an angle from this way or this way. They're coming straight at me, right? Large wave heights, not really 1 or 2 feet, but 4 feet, 6 feet, 8 feet waves, right? That brings really concerning rip current conditions. And longer wave periods. Wave period, the amount of time, measured in seconds, for one wave to complete one cycle. So in other words, you're sitting there at the beach watching the waves roll in. Watch a wave crash. As soon as it starts to crash, start counting in seconds. The amount of seconds that it takes to see the next wave crash is your wave period. That's what we're talking about there. So the longer the wave period, the more you have a rubber banding effect, essentially, where the wave can really suck itself out into the ocean. That creates more rip current concerns out of that. Well, if you're dealing with tropical cyclones or hurricanes or tropical storms or what have you, way out in the ocean, I guarantee you're going to have all three of those boxes checked off. Because a tropical cyclone, no matter how strong it is, basically acts like throwing a rip current in a pond, throwing a rock in a pond, I should say, excuse me. You throw that rock in the pond and you see the ripples that form after the rock. Now, it might take a few seconds or a few minutes for those ripples to reach the edge of that pond, but they do get there. Same thing happens with tropical cyclones in the open ocean. Might take a few days for that big wave energy to make its way to shore, but it always gets there eventually. And it immediately satisfies all three of those rules that we just talked about on the previous slide. You got strong waves that are coming at you at a perpendicular angle to the shore. Large waves, right? They could be 6-foot waves, 8-foot waves, something like that. Long wave periods, I'm talking well over 10 seconds really. 12 seconds, 15 seconds, 18 seconds. That's what we're used to seeing around these areas when we have rip currents from tropical systems offshore. This is a big deal because it creates kind of an awkward balance in a worst case scenario, really. Because you could have a distant tropical cyclone that's a couple thousand miles offshore. Oh, it's in the middle of the open ocean. It's a fish storm, right? It's not going to matter to us here on land. That's a little bit of a white lie, right? Because the weather at the beach might be nice. Here, it might be sunny skies, highs in the upper 80s. It's a nice weekend up ahead, right? A lot of people are going to come to the beach with nice weather like that. But the ocean is dangerous because of that tropical cyclone way offshore. 60% of surf-related fatalities caused by tropical cyclones in the Atlantic were due to distant storms over a period of 2000 to 2022. Great picture that we have to show this off on the right side of the slide. Rip currents all along Wrightsville Beach, pointed by those little yellow arrows there. Shows you all the different rip currents that are going on along the shoreline in Wrightsville Beach, North Carolina. That was created by swells from Hurricane Fiona, which at the time, 500 miles away from shore. Crazy. Not even close to affecting us over land being 500 miles away, and yet it's bringing these dangerous rip currents to shore. We see this all the time. Most years we see this, if not every year. The biggest example of this, you got to go back to 2019 with Hurricane Lorenzo. There's the entire path of Lorenzo out in the middle of the Atlantic. Great, right? It turned into a powerful hurricane, but awesome. It wasn't over land, right? In fact, the closest it got to land was 1,700 miles away. That's great news, right? Yes, for the most part. But the bad news is that it generated significant swell that created a very dangerous, very severe rip current outbreak all along the East Coast. At the end of the day, Hurricane Lorenzo caused 8 drownings due to the swells that eventually made it to the East Coast. Imagine that. Storm that was way far away, and it actually caused 8 fatalities due to rip currents up and down the U.S. East Coast. We dive into the data on that and we look at, okay, taking a look at the cumulative data, all these fatalities that have occurred from rip currents from 2000 to 2022. We plotted them on a map here. We call this a dot density map. This shows you 2 things. It shows you the physical location, number 1, of where these people were from, but it also tells you who comes from more places. In other words, the bigger dots on the map represent that we have a number of individuals from that particular area that have died in a rip current. So like you have a couple of black dots over parts of metro Atlanta in Georgia. And then you have this big red dot in north central Kentucky, looks like around the Louisville area. In other words, we had a lot of people from that same area in Kentucky that have died from a rip current along the coastal regions. So this is why education is so tremendously important, right? It is probably a reasonable assumption that those of us that live and work along the coast have a little bit more of an in-tuned idea about rip currents than folks inland. If you're in a landlocked state, you might not know anything about a rip current, right? Again, this is why education is such a big thing that we hammer every year when it comes to beach season in the spring and summertime. This is why we're doing this video. This is why this stuff is tremendously important. This is life-saving information here that we're presenting. Rip current risk graphic that comes to us from the National Hurricane Center. If there's an active storm out there, you can go to hurricanes.gov and you can click on that particular storm, whichever one you're interested in, any tropical storm or hurricane that's out there. And there's a tab on that page that will allow you to see this kind of risk graphic. It'll break out into colors in grays and yellows and reds to show you how bad the rip current threat is along different slivers of the coastline. And we do this for everybody all along the Atlantic, the Gulf, and the Pacific. So that's a really good tool to keep in your toolkit. Moving on from rip currents, and we focus on other offshore hurricane impacts. Hurricanes have been the cause of many maritime disasters. We see this perhaps every year. The wave growth depends on wind speed, wind duration, and fetch length. In other words, there's a lot of different pieces in play that contribute to the very chaotic environment of what a hurricane can produce over the open waters. While the eye of the hurricane, of a strong tropical cyclone in general, has clear skies and calm winds, it's deceivingly calm. But the sea heights are at their maximum. That's when it's the most chaotic. The eye itself, which is pretty small, roughly 10 to 40 nautical miles wide, you have this dangerous combination of wave directions and periods creating the conditions necessary to generate phenomenal rogue waves. Very chaotic environment. Good satellite image there showing you Hurricane Florence at the time at Category 4 strength on September 12th, 2018. Sustained winds of 115 knots. Due to the large size and the long duration of Florence, 12-foot seas extended up to 300 nautical miles from the storm center, right? So at that point, we're not talking about the eye or the eye wall, right? We're talking about really strong winds and seas that go hundreds of miles beyond the center of the storm. That's a large radius that you're working with there. So you can see how boats and ships are at risk for dealing with that kind of disaster along a large swath of water. This is why planning is so important, right? For vessels at sea, avoiding the 35-knot wind field of a hurricane is paramount. Well, why 34 knots? What's so important or magical about that? It's because at 34 knots or above, the sea state development, your environment, your waves, that approaches very critical levels, resulting in rapidly decreasing limits to ship maneuverability. Okay. It's also important to mention that the state of the sea outside of the radius of 34 knot winds can also be significant enough to limit your course options, where you can go, where you can turn, right? So planning ahead is the name of the game here, right? Never plan to cross the track of a hurricane, or sometimes the mariners call it crossing the T of a hurricane. Don't do that, right? It's not advised because any engineering casualty or reduction in speed due to those conditions will leave a hindered vessel in the worst possible location, directly in the path of a tropical cyclone. Plan early, make routing decisions early, and be flexible, especially as the forecast changes over time, especially when there's a lot of wiggle room when you are 4, 5, or 6 days out of the forecast. Hurricane Center marine forecast information. I got a lot of really good tips out there for you. Numerous forecast products are available from the National Hurricane Center for mariners via both the internet and low bandwidth and radio fax format. This also includes NOAA Weather Radio. Have a lot of really good information within those forecasts. The storm track, the wind speed probabilities, wave heights, peak wave period and wind direction or wave direction, and more. All of those kinds of things packed into the forecast products that are available from the National Hurricane Center. That's all I have. We greatly appreciate you tuning in. We hope this was very educational for you. Please stay safe out there this hurricane season. Once again, my name is Ian Boatman, meteorologist at the National Weather Service in Wilmington, North Carolina. You can find us on our website, weather.gov/ILM, like the Wilmington Airport ILM. We are also available on Facebook, X, and YouTube at NWS Wilmington NC. The Wilmington office is also available on Instagram, instagram.com/NWS Wilmington NC, or of course at NWS Wilmington NC. Thank you again for joining us. Stay safe out there. Cheers. Have a good day.